Hey, hello everyone. Okay, everything's all right. We're ready to get started. So, welcome. Thank you for joining. We're going to do a demo today of game programming in Godot. It's a Pong-like video game with a slight, how do you call that? With a switch, with a... Yeah, it's Pong, but it's not Pong exactly. It's for the end of the Kickstarter that we are currently streaming, gathering together, and yeah, it's been a huge success. So thank you very much for that. Now, how are you doing? Okay, I've got to scale up that window because the chat is way too small. I can barely read it. So, I've got some graphics and some very basic code. Oh, yeah, okay. This one should extend. Now the script. Battle.gd, I think. Okay, so I prepared a small demo. I haven't had time to do everything I wanted to. I've just got a rudimentary system where you can spawn a shockwave and you're going to use that to push the ball out and to give it a lot of inertia. But that's about it for now. And the goal for this video was to talk a bit about AI and a way to do a smart Pong AI, but it's going to be a bit hard. Is the sound okay? Is everything okay this time? Okay, I've got to move that around a little bit. God, it's so hot in here. You can't imagine. It's at least 30 degrees. Ah, that's horrible. Okay, so when you're making a game like that, it's at first you've got to prototype it. So you've kind of got to do all the work at once. I like to start with the core gameplay loop. I won't implement the score and all those things. Instead, I'll just focus on the most visual part and the most interactive part of the game and work on that until it feels good. It's not worth adding a game over or something like that until you've got decent controls to play with. So that's why I started with the paddle. At first it had no acceleration or deceleration. Now it has a very slight one so that you can kind of control it. When it's changing direction, it's not slowing down at all. So yeah, you can nudge it around a little bit if you don't press for long, but it can walk a bit faster if you keep the key down. The acceleration and deceleration are very high. The code is very simple for now. We're starting with something mostly procedural. I've got a ball with a rudimentary state machine. It's very basic. It's not really how you do a state machine, but it does the job in the case of a very small game like this one. We have a ball with 3 states. It can wait, so that's at the start of the game or every time it resets and comes back to the center of the board, it's going to wait for wait time, which is 1 second while we are testing the game. Should be a bit more than that, I think, later on. Then it has a start state, so the idea with that is to have some anticipation, some small animation we're going to do with the editor in a moment. And then we have the move one, which is the ball bouncing like normal. So everything that boils down to the ball bouncing will be down here on the move state. Now for the current version, we're going to skip the start state and jump onto the move state straight away. That'll be a bit easier. The principle of finite state machines, if you don't know what that is, you want to treat your character or your object like it has a finite number of states. For a playable character, it's the easiest. You have the character idle. It can be jumping, it can be walking, it can be running. And you want to separate the code for every one of these states. The way you're going to check for collisions and all, you don't need to do it the same way depending on the state. And the finite state machine is really useful because if you use if and elifs, conditional statements like that, it soon becomes a mess because very quickly you're going to have conditions like if the state is move and something else. And you're going to have lots of checks like these that you'd have to nest and all. It becomes very hard to maintain, very hard to manage your code. And yeah, you end up with a tangled mess that you can't build extra code, you generate bugs very fast and all. So with the finite state machine, you don't. Now, the most basic way to do it is kind of to do it like that. That's the starting point. At least you have some states and you have conditions to go to a certain state. And when you want to refactor the game, when it scales up a little bit past the prototype, you can do that. It's not a huge deal. For the needs of this demo, it's enough to, do the code like that in a very linear fashion. So let's make the ball move. Right now, the existing code is very simple. We center the ball on the board using this instruction. We set it to fixed process because it's a kinematic body 2D. It has to manage collisions and all. There's the wait state, which has a very simple timer. And now we're going to do the move part. Yes, the important thing about finite state machines is how you transition from one state to the next. So basically, each state should have an entering state, kind of like some initialization function, and some function when it exits, so to clean up everything after it. In this very simple implementation, I just have one function, and this is the way you enter the state, and there's no exiting or cleaning up the previous state. But you can do that as well in a simple example like this one. You just store the previous state, and in the goToState function, you store the state in the previous state before you replace the current state with the new one. And then you do a round of checks on the new states that's entering the new one. And to exit the previous one, you just do a round of checks on what the previous state is. But again, it works well for 3 to, let's say, 5 or 6 states. Yeah, maybe even at 5 or 6, it starts to get tricky. 3 or 4 states, you can do it like that. It's no big deal. Making the ball move, we have to give it an initial direction. For now, we'll always send it to the right. Initial direction, it's going to be a vector 2. Or maybe we'll calculate, okay, we'll calculate that. We'll give it a slightly random direction. So if the new state is move, so if you're entering the move state, we're going to randomize first of all before we call a random function, otherwise we'll get the same value every time, and calculate a rand float multiplied by let's work with radians. So I want to get an angle between 0 and 180 degrees. So a float, the random float is going to be value between 0 and 1, and multiplying that by pi, it's going to be a value between 0 and pi. What next? We're going to store it, a variable rand angle. So we want to generate a random angle and send the ball to the right. let's do. We can randomize sending the ball to the left or the right, but I think it'll be better to base the direction, left or right, based on where the ball hit, who scored last time. So we'll do that a bit later. So I'm really tired. So if I have a hard time, saying things or moving forward, that's the reason. Okay, let me think about what we have to do. We first have to take the direction. Yeah, the initial direction is gonna be hard-coded for 1, so it's 1, 0, going to the right. Plus, I've got an angle, I want a vector. Yeah, so let's use some trigonometry for that. Well, oh no, we're going to rotate the vector. Rotated by the rand angle. Minus half itself. Okay, so the reason for that is the random angle is between 0 and 180 degrees. We want to have an angle between minus 90 and plus 90 degrees. So the direction can be rotated towards the top or towards the bottom. And let's see if that works. Okay. Let's add some code to move the ball. We're going to give it some variables because we have to see how it works. So some speed. The ball is not going to accelerate, but its speed is going to vary. So we need a variable. We need some max speed. Let's use 1000 pixels per second. We need a direction. If you have any questions or comments, don't hesitate. Really. Okay, speed, max speed, no acceleration. It should be good. All we need. So the motion of the ball is going to be speed times direction times delta, like usual. And we'll move it using that motion vector we just calculated. Okay, so you were posting in the chat. Actually, the chat got stuck at the top. FSM goodie, blah, 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 blah. Yeah, it's hard to... after working for many days straight, it's very hard to focus. And there's still two more videos to do. That's the hardest part currently, doing the videos right, like keeping the quality up like usual. They actually take more time to produce than when I'm well rested, which is not fun. I have a lot more cuts to do. Yeah. So the ball can move. The only thing is we have an initial direction, but actually let's set the direction directly and we'll forget that for now and see how it works. Run the game. And it crashed. What did I do? Function vector. Forgot the 2. What did I do? No. My ball is a no 2D. Why did I do that? Okay, let's open it. So you can't move something. You can't use the move method. What did I... I see now. Yeah. Don't be tired, people. Okay, let's inherit kinematic body 2D instead, and we'll be fine. Okay. All right. Now it waits for 1 second, and then it should move. So now it's moving, except it's not because the speed is equal to 0. Yeah, let's do it up there. Speed is gonna be equal to max speed. So now it's hitting a collider. We have to handle collisions. All right. My scripting style is very different from yours, the V8. Yep. Might be, I mean, there are plenty of ways to solve problems. This is not how I'd recommend to code a game. This is not how you want to do it if you want maintainable code. But when you are prototyping, it's okay. You can just scan down. I do a bit of object-oriented programming, like you have a base battle and then you have the player and opponent battles that inherit from it. In that case, in this one case, it makes sense because you don't have too much inheritance. You just have one parent for the both of these. I'm inheriting in the scenes and all to make it easier to extend later. But inside of a script, I'm going to use very procedural code, do that, then do that, then do that. And I'll think about maintainability when I know that the gameplay is interesting. That's typical game designer's code here, if you want. Good morning, Straighten. Is it Straighten or Stratton? How do you say that? Okay, let's handle collisions now. If the ball is colliding, we want to bounce it. So let's use direction dot reflect. It doesn't take any argument, I think. Or does it take the normal? Let's get the collision normal. Let's see, reflect. Yeah, it takes a vector. Reflects the vector instead of continuing along the wall. So we're going to mirror the vector based on the collision. And now the trick compared to the original Pong is that our battle is half a circle. I don't know if that's going to work well, but let us try. So we'll reflect the direction based on the normal, and that should be enough just for testing purposes. Yeah, okay, if it goes up like that, it's not going to work. Let's add some colliders to the game board. I'm going to make a new scene for the background and integrate the art so it looks a little better. Let's go there. We want the background, however, should be a background itself should be a Node 2D so that we can just move it around like the container. But we'll need some static bodies inside of it. Okay. Will the 3.0 demos be open sourced? If you mean the demos from the Kickstarter, I'm actually going to work on the official demos. So yes, these are the demos that ship with Godot, and they'll be under the MIT license like everything else. And then if you're talking about the game project from the course, the source code of the project will be commented. You'll have the assets, you'll have the sources for everything as well. And we discussed that with Aiken. And he's interested in having it as part of the official demo. So normally it will also be added to them. Maybe separately if it's a bit big, because it's going to be a bigger game than all the demos you have currently. Let's add some sprites inside of it. We'll need, no. We need some UI components. Texture frame, I think. You have a tileable texture If I search for texture, can a sprite tile? I'm not sure. Centered flip. Now, seems like I can't tile it directly. Maybe in the texture flags you have that. Okay, let me take the wall, for example. Yeah, so for those who didn't know the idea of the Kickstarter, at first, we didn't communicate on that, on the open source part, but only on the paid part, because in order for the project to work, we had to reach a minimal amount of money. And that's quite important. Okay, I can repeat the texture. Does it? Seems like, yeah, it seems good. Okay, so we'll use sprites in that case. Far better. And add the snapping with the snap on. Okay, it's snapping the center position. Where do I change? Bad boy. Okay, it snaps the origin there too. I don't remember if doing that when I set the pivot, when you press a key, it sets the pivot that way. Or is V? Okay, V is the key to set the pivot. Interesting. And interesting too. Look at that. If I place the pivot inside, it's offsetting my sprite. But if I set it very close outside, it's not. It's very weird. I don't know why that's happening. Okay, let's do it that way. Don't really mind. Place it by hand. Hi everyone. Right. It doesn't matter too much if the sprite is longer than planned. It's going to be the wall. No, it's not going to be the wall. The wall is going to be a static body. That is the wall. And the wall will have a sprite inside of it and a collision shape. When I'm doing the hierarchy in the nodes hierarchy, I'm always trying to think about make it logical in terms of object-oriented design. When someone else comes to the project and reads on, no, I have to scale it that way. Oh, God. Okay, let's configure the snap, otherwise it's going to be hard. So, yeah, when you are creating your hierarchy, your nodes hierarchy, you want it to be to reflect the game's design, and let someone who'd be coming to the game a bit later, another developer or anything, when he comes to it, if he's reading the hierarchy, your scenes, he has to understand what's going on. So for example, the background scene contains the game's background. Makes sense, but inside of the scenes, there's always some, how do you call that? Some guidelines, some strict rules that we want to follow. For example, the fact that you have the type of the component that's going to be the main collision type, collider type, like the wall here. And because we have two walls, we're going to save these as a separate screen, as a separate scene. Let's create a wall folder and a wall scene that way. That way we can duplicate the wall in the scene, move it around, flip it. That's no problem. Can we flip the body? So I think we have to edit the child, because there's a bit of shadow along the edge of the wall. I have a single texture for that. So let's grab the sprite, flip it vertically, and I'll move it pixels up. There we go. Okay. It's 5 a.m. The open source license associated was a key point I have not backed, as this is unclear. If it's part of the official demos, it's necessarily MIT for the code. And I don't know what license they use for the assets, but I think they are copyrighted in the official demos. So yeah, basically I'll be following the licensing of the official stuff. Because otherwise it can't be part of the official, if the license is different or incompatible, let's say, it can't be different. So I'd say MIT for the code is certain, and then I'll have to ask Aiken. Some people recommended CC 4.0 for the assets, but yeah. I'll see, because CC0 is good too. I mean, they don't make a big difference. In both cases, you can use the assets commercially. Okay, so let's save the background scene, the background folder. That's okay. Hold on, wasn't there a shortcut to move things up? Control, nope. Control up or control down? Yes, that's that. Okay, so let's go edit scene, and I'd like to see the sprite on top. It'll be a bit more convenient. Flip the sprite, move the wall. Okay. So if you have any questions, okay, it might be a bit imprecise, but that will be fine. We'll need some extra walls on the sides. I think I'm gonna do it the quick and dirty way. You have no angle snapping? I hadn't noticed. Okay, let's rotate you 90 degrees. We'll move it out of the way. This is very dirty, don't do that. Now, really, when you're prototyping, do anything. As long as it works, it's fine. Okay, the ball goes around and never bounces. Because there's no background in the game. Don't stream when you're tired. It never goes well. And I'll remove the wait state. Go to state, move from the get-go. Okay, it doesn't reflect. It stops against the collider. Why is that? Because we don't grab the movement remainder. Let's grab that. Want to reflect it, and remaining move want to get okay, we want to get want to set the direction Ah, okay, I forgot to set the direction, but normally we want to reflect the part that was remaining from the what's happening? Ah, yes, not moving it anymore. Yeah, okay, that's working. Now we still have to do a few fixes because you can see how it gets stuck in the wall sometime. And that's because of the way we're handling the collision. There's a bit of movement remaining normally when the character hits the wall. So I'd need some, I'm gonna grab Affinity and draw it on screen. Yeah, let's do it that way. So say, what if I do that? Okay, I can get a decent stroke and make it a bit wider. I'm doing it with the mouse, so it's going to be ugly, but fear not, it's going to get the point across. So when we're hitting the wall like that, say the ball has to travel something like, please. Yeah, let's say the ball has to travel that amount here. And when we're hitting the wall, if we stop there, we just reflect the vector and the ball stops, so it moves maybe a third of what it's supposed to move. And then on the next frame, we move it again in the new direction. So it gives you that hiccup. And what we want to do is during the frame when it's colliding, we want to move the ball like that, like reflect this part down that way. So let's do it. There was a question. You know how to make an object only visible when light hit it on 2D? I use Area 2D to do it now. The result isn't realistic at all. I want part of the object that gets light to be visible. Is it possible on 2D? It's always possible with shaders. You'd have to code a shader for that. Then I don't know if the 2D lighting system supports something like this. I think not. But yeah, the idea, if you only want to get part of a sprite visible, you have to multiply its alpha with the light's alpha, basically. And then you can clamp it, so only part of the object will be visible. So yes, it's possible. Okay. So we have our collision normal and the motion remainder. We're going to move the sprite again using the new direction. Okay, we set the direction to be reflected, and we want to move using the move remainder. Hold on. We want, yeah, let's do it directly. I'll move using move remainder times the direction, but if we do it that way, it's not going to work too well. We want the length of that vector, and we'll multiply it by the new direction. So we move the amount that was remaining, the magnitude that remained, we use that as our travel length, and we set it to use the new direction. So now it should work a bit better. And it still gets stuck at some points. I'm not sure why, but it will have to do. Okay, let's go back to the background, and now I need some areas where the ball will be reset. Let's grab the walls 2 and 3, I think. Yes. And we'll add some areas. Okay, top. Rename that so it's clear. Wall bottom. And then we need some areas on the side. How do we call them? Do you have any idea how we can call these? Going to be outside board limits. Yeah, let's call these the limits. We'll need some more static bodies, at least one more with a collision shape. And a new collision shape. Again, a rectangle. There we go. I think an area would be a bit better for that. Change the type here. Okay, so we'll use the area to detect when the object is entering it. Let's see. Okay, let's use this area. Save it as part of the background. Yeah, outbounds or outside limit. Oh, I've called the thing limit. Let's call it limit. And place it there. Okay, so when you're going to hit one of those two, you want the ball to reset to the center. So I'll add them to a group called limit. Okay, so when the ball hits something from that group, it's going to not going to bounce. Instead, it's going to die. No, it's going to come back home. I think using a signal would be smarter. Not sure. When it's colliding, can I check what it's colliding with? Is it collider metadata or have the collision position normal? Probably. Yeah, okay, so it's going to be get collider. Okay. Collider. Let's check if it's in. We just want to know if it's in a group, actually. And the group is called limits. Limits. Go to the wait state, otherwise that. "24 minutes until the Kickstarter closes." It's 11:40 already. Quick question. When should we initialize with Unready? What does it do? Unready does nothing different from the ready function. It's the same thing. So it's only if you want to enable like initialize variables inline when you want to get a node. So a variable node equals get node something. Instead of like you want this variable to be available everywhere and you'd like to initialize it as soon as you create it, you can do it with the Unready keyword. That's about it. And there's also you can use Unready to load something. So let's say paddle equals preload or load the resource you want, whatever script or scene you want to load. And then that way you can use that inside of your script. But if you do all that inside the ready function, as long as you initialize the variable here, you can always set it down there. It's just that when you are programming, then you need to check up to see where it was initialized, where that variable is inside of your current domain. All right. And I have to add something else. Now, when we enter the wait state, I want to reset the pose that way. And because we're doing it twice, I'm going to copy it. And how is it? Ah, yes, it's Control R, and to reset it with the start pose. Install that at the top of the screen. So set. What did I do? Okay. So in general, as well, when I start to have 2 or 3 references to something, to an expression, I will store it, especially if it's something as common as the starting position, which I might need in other places. I don't know just yet. In general, I like to keep the code in line, but for this, I like to have references to the important variables that define what the character is and what it does. I like to have all that at the top of the script, because it's very easy then to get a sense for the behavior of the class. Let's replace that with start position, and we'll put it up there. We'll store the start position using get window size divided by 2. Works well. Okay, let's see. God, it's getting even hotter here. It's horrible. There's climate change happening in my office right now. It's not taking dozens of years. Okay. I think this is not working. I'd like to know why, though. Doesn't print anything, so the collider is not in the limits group. Is it colliding at all? Huh. I have no idea of why it's happening. We don't want to use a static body here, but let's see if that changes anything. Yeah, okay. It's just because it's not colliding with the area, but it's detecting that the sprite is entering it, or the ball is entering it, rather. So I guess that if we're using an area, we would have to, I don't like the idea. We would have to send a signal, connect a signal from that. Yeah. Okay, let's keep it that way. Okay, there's a bit of a gap, but as long as it isn't too big, be okay. The ball should never get out of it. Make the collider longer. That should be fine. Okay, quick and dirty tactics. That's just so that the ball goes out of the screen, at least partially, before it comes back to the center. So you can see the states working, no problem. The paddles are way too big though. And the ball is going way too fast. Oh, the bounces are wonky also at times. it'll have to do for now. That's really strange. I'd expect the ball to mirror, really. Like to, because normally the collision normal in that case should be pointing up from that wall and pointing down. When you reflect the vector, it should give you a pure mirror. So I guess that, yeah, let's do it. Instead of reflecting the vector, let's do it manually on the ball. Oh, it's printing Yoho every time it hits the wall. So, yeah, instead of using the collisions like that, we'll want to not reflect it, but we just want to change the Y direction. And that'll be enough when it's hitting the walls. But then for the paddle, it's... Yeah, it's really strange. Normally the... is the direction and the right way around your reflect call. In all honesty, there's... vector 2s are super useful, but the problem is the documentation of the class. You don't really know how the functions operate, so... like reflect, I have no idea how that works exactly, because the description is just like slide, but reflects the vector instead of continuing along the wall. If you refer to slide, it slides the vector by the other vector, which means actually there are at least 2 ways to do that I can think of, sliding, and yeah, it's... shouldn't be and.reflect direction. Yes, absolutely. You're right, Chris. Thanks. That's true. Go back. There we go. It's true that it's the vector that's calling the method that's doing the operation. So it has to reflect the direction. Okay, let's try that to see. Seems to be working a lot better. Yeah, thank you. Okay. What program do you use for the drawing? It's called Affinity Designer. I'll post it in the chat. Not for this one. Affinity, I've used vector shapes. God, it's getting hard to focus, like... All right, now I just need to fix the paddle, because the collider... First, the collider is too big. Is it the ball or the paddle? The ball is the right size, normally. Really strange. Make it slightly smaller. How come it's not centered? You're centered. And it's only when I'm zooming in, it seems like the ball sprite is a bit offset. While it's placed on the origin, you are too. I think I should have imported all the textures. Because, yeah, you get some wonky effects at times. Yes, it is Affinity Designer. That's written. You can see the logo in the top left corner. Okay. So then I have to look at the paddle. collision shape is a bit big as well. Let's... See, it's a bit... It's really hacky, the way it's done right now, but it should be fine. Yeah, there's the same offset problem as you can see on this picture. Well, normally everything, this one doesn't seem, yeah, slightly offset on the y-axis. Yeah, so basically we're using a circle collider, and the idea is moving forward, then we'll ignore the left part of the collider by checking the collision normal. So right now it's kinematic body. I think it should trigger. Now, let's see if it works with a trigger. No, it doesn't. Trigger only tells you, yeah, it doesn't collide. It's only going to kind of signal or tell you that you entered some shape. Let's keep it that way for now. But it feels like the ball is colliding with an offset or something like that. Yeah, Affinity is for vector drawing, and it's very cheap and very powerful. I'd actually recommend it over Illustrator, even for professionals. And then Inkscape is the open source vector program. It's the biggest one. I have a hard time with it because the drawing tools are very good. There's no problem with that, but it's missing plenty of things that I use all the time, and the program is not making super fast progress. So for most people, it will be fine. For me, working professionally on art, when I have a ton of work and I need to work fast, it's a requirement. Having a fast program is quite important. Okay, you didn't miss too much, really. It's not really a class, I must say. It's nothing exceptional. I'm starting to lose my voice on top of that. All right. So now the thing is, the whole point of the game is that, the shockwave. It's spawning on top of the characters, but basically, let me show you how I did it. The shockwave is animated using the animation editor, including its collider. So the idea is to have that. I have the collider as a static body 2D. Now this one should be a trigger. I think I set it. Yeah, the shape is a trigger, so it's not going to do anything to the ball for now. Maybe I could, we could try if we have it without a trigger, it should work. And I've attached it to the paddle. Should really use that. So I've attached it to the paddle. You have the shockwave right there. You can see the collider. But inside of its script, it's a very simple script. You just have some fire function. It's a signal that gets sent by the player to the paddle. And it is set as top level so that it always appears like it's how can I say? It's positioned in the world. Yeah, okay, it actually works. That's cool. It's set as top level so that its position doesn't depend on the player. So you can see when I generate a shockwave, it stays in place. So the idea in that game is to have a very small paddle with which it's very hard to hit the ball, and use the shockwave as a shield to send the ball on the other side. Are you sure it's not your movement reminder? So going back to the ball. Ah, yes, it's the movement reminder that sends the ball away before it hit. Okay, so we'd have to move the ball after the collision, but 1 frame after it. That's interesting. So we have to stop the ball. How do we do that? Let me see. Yes, that's true on top of that. Yeah, the angle is pretty bad. Whoa, some wonky things happening. Yeah, that's just for testing purposes, but it should definitely not be. The shockwave should definitely not be a collider. It should be a trigger. And I definitely should not be teaching you being that tired. Or trying, rather. Just trying to understand what's happening right now. Some wonky things, the way I implemented the game. Yeah, it looks like the hitboxes are too big, but they actually fit the characters on the ball. So I just have to make the ball collider smaller, maybe. And let's try making the battle one even smaller. Well, the problem is not just the collision shape, it's both of them. The battle itself is a bit too big. Is that an elliptical collider? You know, this capsule. But I think that the capsule can... I know it retains its shape. Let's see. Let's see how that works now. Yeah, there are way too many things I wanted to do, and I haven't had time to. It's good to see some Pong fu. Yeah, that's the idea. Okay, it looks a bit better now, the interaction. Okay, let's implement some basic AI just to change our mind and thoughts on the opponent battle. I wanted to show you something interesting, but that's going to be too tricky. Like the typical Pong AI, when you learn to do it, and the thing you'll see, even if you see a tutorial, I guess that's the one you'll see all the time. You make the battle move following the ball. Basically, do something along those lines. Let me see my game scene. Yeah. So you want to get the ball. You get the node. You go one step up and then you grab the ball. Okay, so you get a reference to the ball and you just track it. So you want to give it maybe a fixed speed. Let's say the ball has a speed of 400, something like that, to get started. And we're going to move in the direction of the ball. So let's store the direction up there. Normally it has one, I think. The paddle has the direction. It has direction and speed. Okay. So the direction of the enemy paddle is going to be based on the ball's direction. On the y-axis, And we'll grab just the sign of that to get plus or -1. I think that should return that. So we grab the current direction of the ball, and that's going to be the paddle's direction. It's just going to track it. Let me see. Now we're going to move towards the ball, not just grab the direction of the ball. It's going to be the sign of. Sorry, I'm losing my thoughts here. Going to be the sign of the ball's Y position minus the paddle position on the Y-axis. Let's see if that works. Let me think. Ball is above. It's going to be negative. Yeah, okay, should be good. And then the motion should be your speed. Yeah, that's the idea. You move the paddle towards the Y of the ball. Now there are several ways to do it. So a very simple one is to you take the Y position of the ball, and if it's above you, you move up at a certain speed, and otherwise you move down. So that's the idea here. And then, as DemiPixel is saying, you may not always send the paddle in the right direction. That doesn't look too well. And what does the sign bit do? The sign normally gives you the sign of the operation, and it should return 1 or -1. Let me check. Yeah, it returns -1 or +1, so it gives you the direction you should move into. And now when you're making an AI, you want to have some control. And speed times direction, using the motion, and we'll set the speed to something like 400. The problem is this AI is completely flawed. Yes, I forgot to add the X component. Wow, I forgot delta. Psst. Come on, seriously. Ridiculous. Yeah, so that's the idea. That's the basic Pong AI you have here, which is quite bugged right now. But at least the motion, you've got the idea. Now, if it's within a certain radius, basically when it's in front of the ball, you don't want it to move, or otherwise it's jittering like you've seen here. So you want to define some limit for that. If the ball's position, you're going to check the distance to the ball. So if the absolute value of that is less than, let's say, 30 pixels, 20 pixels, speed is going to be 0, something like that. So that's quick and dirty code, but to show you that you can make AI very easily. However, this AI is completely flawed because there are angles. It's going to be limited by its speed, and there are angles where it just doesn't work. Now, there are some problems with the collider, the way it's implemented right now, but it should. For fun, you could also check if the ball's velocity is negative and then make it stop moving or decrease the speed. Yeah, so there are plenty of ways to make the ball fail. can lower its speed at times temporarily, like decelerate it to let the ball slip and all. The problem is control. It's very hard. The way to implement a robust Pong AI, especially if you don't do the regular Pong game, because you can see it's failing in this one, especially when we start to add the shockwave, be failing pretty hard. You'll want to do something along those lines. I'm going to switch screen right moment, like that. It seems it doesn't want to update. Yeah. Great. Let me grab, I'll open another instance. Close this one and open a new one. There was a question about why do you use delta. I think I saw the same one on the... why do you have to use the delta? Yes, because the speed is in pixels per second, and to get a motion, to know how much you're moving, a motion is in pixels. It's only a distance, so you want to multiply by a time value to get that distance. Yeah, the thing is you have to use some tricks in the current version of Godot to make the collisions work, and I didn't have time to implement the game before that. Like, I've had literally 2 hours before the stream to do it. Because as the Kickstarter is closing, there are lots of emails, messages coming in. You get distracted a lot. Like, literally, I answered at least 10 or 20 messages this morning. So, yeah, the idea with a more robust Pong AI would be something like that. So let's increase that size a bit. Everyone sees what's happening. So you have the ball, and when you hit it with the paddle, it's going to give it an impulse. So the ball has a direction and has a certain speed. Now, the thing is, you can calculate where it's going to land, because it always bounces the same way. It always mirrors like that. You can calculate where it's going to land exactly. And I said there are several ways to do AI. So one is to use simple tricks. And the other one, which is generally the method you want to follow when you make a bigger game, is to make the AI perfect, knows exactly how to beat the game, how to beat the player every time, and then you can set rules so that at times the game feels more fair. Basically, you do things like, let's say the AI is perfect. It always gets the ball. You make it so when the player succeeds, makes a better impulse following the rule of the game. So the idea with the shockwave is if you hit the ball, the paddle should be very small. And if you hit the ball around the center of the paddle with a very small shockwave, like if the ball hits the paddle, it should take damage or something like that. It should slow down, something along those lines for some time. But if you hit with the shockwave while you're in danger, while the ball is very close, the ball goes a lot faster. But still, the AI knows exactly where to go to hit the ball. It can have a sense of where the ball is going to land, just like the player can. And then you'll do it so, you'll design it so when the player plays better, basically, the AI might fail a bit more. Like, you'll lower its chance of getting the ball down to 90%. And then the way you move it will be a bit like you'll be playing. We had that once with a game where we had an enemy be like, you had the ball going around on the board, and the enemy would shake a bit, or it would, instead of going straight in the right direction, it would stop, it would jitter a little bit, but knew exactly where it had to go from the start. Like, it's entirely fake. And AI is like that a lot. So in that case, I really shouldn't do math live, but I'd say to calculate it, you have to split up the direction into I'd do it that way. I know I can calculate how much you have to travel on the X and Y axis to do the first bounce. Then I know I can calculate the length of a bounce, and I just have to calculate what's left on the last one to hit that line, right? I'm not going to implement it live because I'm going to fail miserably. That's really something I should prepare. But so a perfect Pong AI would be for the pad to always track the center of the ball with the center, so the pad locks on the ball. Yeah, that's the idea. So basically the pad should know where the ball is going to land. Let's say it lands here, for example. It knows that. It should just move so that it doesn't have to be centered on the ball, but it should move so that it's kind of in front, like it's going to collide with it. But yeah, that could be you set this as a target and you let the AI move down there. That would be the perfect thing. Instantly, as soon as it knows, you move it down there, it sits in front of the ball, and when the ball hits, it sends it back. That's a perfect defensive AI, but that's not perfect in the sense of beating the player. So the whole difficulty is you need to have some information about where the ball is going to land, and then you need the AI to take decisions. For example, the AI might want to instead come around like that to send the ball at a steeper angle, like hit if there's some roundness on the sides and all. It should try to send the ball at a steep angle. Yeah, it depends on the rules of the game. But that's the idea. I'm going to close the stream soon. Hey, the Kickstarter is over, by the way. Is it? Yeah, it should be. Okay, it's done. 400% funded plus PayPal. Okay, it's big. It's really been big in the last 2 days. All right, so that's good news. I have to say thanks everyone. Thanks everyone who's here, backers or not. Everyone who supports, the channel and the project. But also, yeah, that's huge. That's really huge. Okay, so it's you can expect to have me around working with Godot for a long time, but at least working on it full time for a year. So yeah, the way I do it is normalize the direction, take the direction vector, calculate the ratio, calculate how much you have to travel on the x-axis. And so how much corresponding to that you'll have to travel on the y-axis in total, like the added y length. And so, yeah, then you calculate the length of a bounce on the x-axis, and you find its corresponding length on the y-axis. It's going to be always the size of the board of the game. And once you have that, you use the modulo operator from the ball position to the enemy position. You track that, and you'd have to use the modulo operator to see how many times you can stick that bounce length inside of that, plus the initial bounce that you subtract from it. So from here to here, you check how many bounces you have, let's say 2, and from that you have the remaining X motion, you have the last bounce position that you can calculate as well. You can calculate where the ball is going to land. Maybe there's a better way to do it using trigonometry. Yeah, Chris's comment is a very good one. That's one way to do it. So you can do a simulation. That's one way to do it. That is, you virtually simulate the ball doing that, and you check when it collides with that line, when it intersects. Performance-wise, it shouldn't be a problem. But I'm not sure. I think there are more elegant ways to do it. Like, it works. So simulation is very common with bullets and all. Often you use raycast for that. So instead of like calculating everything with math, you can do it that way. So you don't have to simulate the ball, but instead you send raycasts and you check the intersection point. You reflect the raycast. You check the intersection down there. And you reuse the angle from the first raycast, and you check the, like, you loop over, you do those mirrored raycasts until it intersects with the enemy line. It's probably the easiest way to do it. Like, you don't have to do any maths and all. Godot will handle it for you. So it will find the intersection points every time. And so that way you can, it should be, like, there should be a slight error, maybe a slight floating point error or something like that, but it should be pretty accurate. So yeah, that's probably the way to do it. Otherwise, I wonder, I'm sure with trigonometry, there should be a way to calculate it, given few parameters, but I'd have to do some algebra to find it. But yeah, you can see there are a few solutions. All that to say, you want to do a few things when you design the AI. So you want to calculate that ball landing position, but then you'll also want to track the player's input when the ball is going towards him, to adapt the AI strategy based on what the player is doing. So it's a good thing for an AI to listen to the player's input. The AI can be godlike, know everything about the game, everything that's happening, and take decisions based on that. That's what they do in most AAA games, even smaller ones. Like when the enemies don't follow patterns, instead they tend to do that. They listen to the player's input, and that's how you define if the player is being aggressive or something like that. And yeah, you also check it against the position in the world and all that thing. Or pretend it's going in a straight line upwards to the demipixel. Exactly, yeah, that's a very good one. So yeah, you can pretend the ball is going like that. The only thing is the last bounce can be the same direction as the ball, or it can be the other one. Let me think. Problem is, you still have to calculate, you still have to do some calculations. Do you know if it's going to bounce an even or uneven number of times? A mod by height. Yeah. Yeah, so demipixel's solution is probably the easiest one. You pretend the ball is going in a straight line up until the final line. And then you just check compared to the height of the board. If you can divide the number or the modulo, you can you can flip it with the modulo. You can get the last bounce direction with the modulo operator. Okay, so we've probably got the easiest way to do it now. Okay, I'm going to close the stream now. We've talked about a few things, and we have a wonderful buggy game to enjoy, to play with. But yeah, we kind of have the basics. I'll refine the code a little bit, at least to get it working in a basic way, and put it up on GitHub like usual. I think with the enemy paddle, there's also the shockwave interfering. I'll have to fix that. Okay, any questions before we close? What time is it? 20 past 12. Yeah. Time to have lunch. Going to eat and get out of that oven. It's very hot in here. So no questions, it seems. Maybe there's a bit of delay on the stream today as well. There are no bugs. They are features. Exactly, John. Exactly. Yeah, no, I'd need to work on something like that for a day to prepare it for the stream. But at the same time, I didn't want to do an empty stream like last time. At least there was a bit of coding this time around. Legendary, you'll have the replay just after the stream, so no worries. All right, seems there are no questions. Thank you kindly for watching. Thank you for the support during the Kickstarter. I still have 2 videos to do. I'll be working on it this afternoon, but I might delay them because I'm really tired to take a few days off, so that way the quality will be a bit better. I'll see that. Yeah, I think I'm going to take the end of the week off because you could see how bad that was today. Weeaboo has a question. How will you distribute the Godot course? Okay, so all the products, everything I do is available on a shop on Gumroad. So I'll put the course up there. Now, for now, that's the only platform I'm using. And that will be for the paid part, for the premium course, right? The thing with Gumroad is it allows you to download all the files. You can stream if you want. You can read the PDFs. It's stored in a library, a bit like on Steam. And yeah, talking about that, there was a request to put it up on Steam so that people who live in countries where they don't have the same currency and all, you can adapt the price based on the currency rate, based on a variety of parameters. So that's something I'm going to look into, but it will only come after the course is over. Then for the rest, you will find it there, I think, part of it. I'm actually glad we can work together, so you'll find some of it in the docs, because I'm going to redo at least the step-by-step tutorial entirely. Yeah, Gumroad is pretty popular among independent workers in the games and CGI industry, I'd say. It's used by artists. I'd have to check with itch.io, but I think you cannot put videos up there. Like if you could put the files and all, because it's a really nice platform, and maybe we could put up the final game in HTML5, embed it. So yeah, I'll look into the channels, but the main one is going to be Gumroad and then GitHub and the official docs and all. Yeah, so basically, John Smith is talking about Shopify. And Shopify is a platform where you host your own thing. Now with Gumroad, I have an API, like I can do a few things via script, which save time. And I can, the thing is, Gumroad works as a mailing platform as well. Emailing costs a lot of money. And with Gumroad, you have all the features done for you. So whenever I update something, you get an email saying you got an update, it's in your Gumroad library, this, that, and that changed. And the goal with the course this time around, I think I'll be updating it once a month or once every 2 weeks, basically when a module is done. So thank you kindly for watching. I guess that's it for now. And yeah, have a nice day. Yeah, Gumroad is more convenient. It's feature packed. It's very well designed. The reason I got into it at first was that it's extremely simple for you when you are coming to the shop looking at something. You can just select the version. I want this. Done. You can pay instantly. You can pay with PayPal if you want. So it has everything. It's convenient. It looks good. You can embed it on a website, or you can just keep it on the Gumroad shop. It's very simple. And when you watch a product, you don't have ads and all that stuff. And yeah, it will be DRM free, the course. Okay, time to close. Thank you kindly for being here. Be creative, have fun, and see you very soon. Yeah. Thank you again for the Kickstarter. Okay, bye-bye.